Hey everyone, what we want to do here is talk about the gyroscope that we saw in class today. So what we said is gyroscope is just a free wheel that is rotating around a fixed axis and is trying to maintain its constant angular momentum in the same direction in the absence of external torques. And when there is an external torque, we saw some weird phenomenon happen. So let's look at this idea of the gyroscope and how we can increase or decrease angular momentum. What we're seeing here in the video is that if I want to apply a torque to this wheel, I have to apply a force along that radius. That radius goes from the center of the spoke out, and I'm labeling that there with the R. I'm going to apply my force down, and if I curl with my radius cross force, you can see my thumb is pointing towards you, which means the torque is towards the screen. So the more I torque this, the larger the angular momentum becomes. And I can find the angular momentum easily using the direction of the spin. If you curl your hands in the direction of the spin, the angular momentum is also pointing out towards you as well. So that means that if I have a torque on an object, the object was at rest, the longer I applied that torque, the more the angular momentum increased in the direction of the torque. So the more I spin it, the more I'm creating that positive torque, which is also giving that positive angular momentum out towards you. To stop the object, I now have to apply a force in the opposite direction. So when my hand grabs the wheel to stop it, the torque now, if you do R cross F, is right through me, back towards the board. And that torque is in the opposite direction of the angular momentum, so it's going to decrease the angular momentum as time goes on. And you can see the R cross F and the right hand rule showing me the direction of the torque. Now the next thing we want to do here is if I was going to try and create a torque using the wheel's own weight, and I'm going to pivot it off of that endpoint where the string is. So the radius is the green, the force of gravity is downwards, so that means there's a torque out of the screen again in the positive direction. That means that if the torque is out of the page and I hold that about its axis point, the object will want to spin in the counterclockwise direction. There's a change in omega in the counterclockwise direction. When Mr. Campera comes along to help us out here, what he's doing is providing a torque from the bike wheel, a frictional torque from the bike wheel that is now pouring angular momentum into my spinning wheel. So this can get it going a lot faster than I could on my own. And now that we have the wheel with angular momentum, and we know that there's a torque because I'm going to pivot it across my finger, that torque is going to try and change the direction of the angular momentum. As that torque causes the momentum to change, the wheel starts to precess and rotate around as long as that external torque is present. So the torque is in one direction, the angular momentum is at 90 degrees to it, is in the direction of the spin, and that torque is going to try and rotate the wheel in the direction of the torque. So let's set this up. We said that there is an external torque. That external torque is going to try to change my angular momentum. So just off the spin of the wheel, using your right hand, you can see the angular momentum is pointing out and towards the right. Doing the right hand rule here for your radius and your force of the wheel gives me a torque into the page. So the torque is going to try and change the angular momentum from pointing to the right to pointing into the page. Since torque causes changes in angular momentum, the gyroscope begins this whole precession idea. You can see that the torque is pointing into the page, and the change in momentum is going to have to be into the page as well. So this is where we started to try and solve for the rate at which the wheel precesses around a circle. So to solve for the rate of the angular precession, I need to know the torque of the wheel being caused by gravity. So that means I need the weight of the wheel multiplied by the distance from the pivot. Since torque causes a change in angular momentum, I can write torque equals change in L over time. And we want to solve for that rate of precession. So we want to solve for the angle that the wheel precesses around the circle as time goes on. And you can use that idea of similar triangles again. so that if my angular momentum changes direction from pointing to the right to starting to point backwards, during that time we have swept out an angle of theta. And since the hasn't changed the magnitude, just the direction, we can say with similar triangles here that theta would be equal to change in L over the angular momentum of the wheel. So we do have change in momentum here in the torque equation. Change in momentum is going to be torque times time equals change in L. So I can put that over here into my theta equation and get mass times gravity times distance times time all over the angular momentum of the wheel. And if that's theta and I want to get omega, I just have to divide theta by time. When I do that, I eliminate the time factor and I'm left with the torque of the wheel over the angular momentum of the spinning wheel gives us our rate of precession. So if I wanted to make that wheel precess faster, one thing I could do is get a heavier wheel. I could have a longer lever arm, or I could decrease the spinning momentum of the wheel. That would make the precession go faster. When I had the bike, I was increasing the angular momentum of the wheel very, very quickly. What that did was what decreased the rate of precession. So the wheel precessed slower around that circle than it did when I did it by my hand and slowly had the wheel going around. So precession is just a phenomenon that happens due to external torques causing the angular momentum of a spinning wheel to try and change. So I do suggest looking at a few of these videos here from Smarter Every Day and Veritasium. They have ways of trying to explain gyroscopic precession and this concept of angular momentum through bike wheels again, through flipping cats. So click some of the links above and explore this idea a little bit more.